So now we're going to talk about another compound that violates the octet rule. This one is going to have more than an octet. Okay, now we remember an octet is 8. Um, and when you're filling in the 2p orbitals, something like oxygen, nitrogen, carbon, you can't violate the octet rule. So if you ever see something like OF6 or something, not going to happen, because if you're filling in the 2s and the 2p, you're way up to the top of the periodic table and you can't access the d orbital, which doesn't start until 3, and that's what you need to be able to do to violate the octet rule. So, the most common elements you'll see in these octet violators where they're doing more than an octet are going to be something like phosphorus or sulfur or something like that, okay? But just remember, nitrogen, oxygen, carbon, those things are really common in compounds, cannot violate the octet rule. So the one I picked for us today is PCl5, okay? If you're getting your naming conventions down, the first thing we need to think about is this an ionic or a covalent compound? So I go to my list of electronegativities, and chlorine is going to be 3.16. And then the phosphorus is going to be 2.19. 16 minus 9 is 7. 9 minus 1 is 8. So that's really going to be only a 0.87 difference, okay? So it's definitely a polar bond, but it's not anywhere near the greater than 2 that we would need to actually treat that as ionic compound. And we wouldn't expect it to be, because phosphorus is a nonmetal with 5 valence electrons, and chlorine is a nonmetal with 7 valence electrons. And so when two nonmetals bond, they don't make ionic bonds, they make covalent bonds. So that's what we see here. But once we've decided that we have a covalent compound, we need to make a Lewis structure. So I've got one phosphorus, and it has 5 valence electrons, so that gives us 5. And then for the chlorine, I've got 5 of them and 7, and so that's going to be 35 and then 40 total, okay? And so, again, the central atom has to be the phosphorus, because phosphorus, in this case, we know that it usually can take 3 bonds. That's what we see, because it has 5 valence and it has 1, 2, 3 hanging out there, and then it usually bonds. But in this case, we have to attach all the chlorides to it. So let's go ahead and do that. And so, just doing a Lewis structure, I just kind of put them out there around the star, and that's fine. It doesn't really matter when you're doing a Lewis structure. It's only when we do our 3D drawing that you have to worry about orientation and how things are, going to be actually focused in space. So I use 2, 4, 6, 8, 10. So that gives me 30 left, and you can see how it's going to play out. I've got 30, and then 30 divided by 5 is 6. So each of these chlorides gets 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so that's a good Lewis structure. And we see that the phosphorus does violate the octet rule. It has 10 valence electrons. And that's okay, because what happens is the chlorine, when it comes in, is so electronegative, and it really wants to make a bond. And so it actually kind of breaks up that unshared pair on phosphorus, and each chlorine takes 1, and then the phosphorus orients itself, and it's fine. Okay? Now, if you want to do a formal charge here, it would be 5, and then minus, you don't have any unshared in phosphorus, plus 1/2 of 10, which is 5, So that's 0. And then the chloride is 7 minus 6 unshared plus 1/2 of 2 is 1 is 0. So the formal charges work out for that. So that makes it okay that phosphorus violates the octet rule. Now, if we want to actually figure out how to draw it, you guys first are going to have to start looking at your charts, because this is not my first chemistry rodeo. I know that things get as far apart as possible. And when you have 5 things, as far apart as possible is you have 3 things kind of around the belt, the center, and then you have 1 on top and 1 on the bottom. Chlorine, 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 chlorine. And so you get this, okay? Now, if you want to kind of mess with it, you can get some pipe cleaners or something and bend the shape if you want. You can kind of look at it. The other thing you can do is kind of put things out on a table in front of you. And let's see if I can show this here. Okay. So this would be around the belt, and then you've got 1 on top and 1 below, okay? And so that's as far apart as 5 things can be when they're around a central hub. And so that's why we get this orientation, and you see there's the 3 that are laying on the table, and there's 1 that's going straight up out of the table, and there's 1 that's below the table, okay? And so this is called trigonal bipyramidal, which means it's a triangle, and it makes 2 pyramids, and the angles are 90 degrees, the top and the bottom, and the 120, you have to have them both in order to be correct. So you got 90, 120 trigonal bipyramidal. I'm sure you guys really want to see why it's a triangle, so I will show you. So there's your triangle, and then when you take the top, there's your first pyramid, and then I'll change color to blue. And then when you do your bottom, there's your second pyramid. So you see trigonal, triangle base, bipyramidal, 2 pyramids.